So what do they want us to do here? They want us to look at the graph y equals x cubed by plotting points and find any intercepts and find any intercepts and check for symmetry first. Okay. Well, let's go. So finding intercepts. So first off, let's find x-intercepts. Well, normally I find y-intercepts first because it's easier, but let's find x-intercepts. So what is an x-intercept? Well, we just make the y value equal to 0, as always, because that's always how you find x-intercepts. And so we say 0 equals x cubed, and we solve for x. And what's the cube root of 0? 0. So our x-intercept is x equals 0. And if you're following along at home, then you might notice that when we go to find the y-intercept and we make x equal to 0, well, y is going to be 0 because y is going to be 0 cubed. So y is going to be 0. And that makes sense because you can only have one of them. You can only have one y-intercept. And we saw that we have the y-intercept there. This is also an x-intercept. And then what about symmetry? They wanted us to check for symmetry. So let's see. What is this function we have now? We have that f of x equals x cubed. And how do we check for symmetry? We did that last time. We did that a couple of days ago. So let's do f of negative x. And we're going to see what we end up with. So what is f of negative x? F of negative x is negative x cubed. And so what happens when you have a negative cubed? You have negative times negative times negative. So that's negative. So you end up with negative x cubed, which is just the negative of the original function. You see, we started with x cubed. We plug in negative x. We get negative x cubed. And so by definition, because f of negative x equals negative f of x, that means this function has origin symmetry. It means if you flip it over the x-axis and the y-axis, it lands back in on itself. So now I think we're ready to graph it, and we should have a decent idea of what it looks like. And it says we should graph it by plotting points, so let's plot some points. So when x is this, y is this. So let's start at negative 2. So when x is negative 2, what's negative 2 cubed? Well, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So we plug in negative 2, we get negative 8. Keep going, negative 1. Negative 1 times negative 1, positive 1. Positive 1 times negative 1, negative 1. So we plug in negative 1 and we get negative 1. 0 cubed is 0. We've already done that. That's our x-intercept and our y-intercept, actually. So we might as well plot that point. So we already found our intercepts. And then positive 1. Well, positive 1 cubed is 1. 2 cubed is 8. And so those are the points we can use. Maybe move this up a little bit so we have some more room. So if we go negative 2 and then negative 8, so down 8. Ooh, a little off. That's about right there. And then negative 1, negative 1. 1, 1. And 2, 8. Oh, this is going to be off too. 4. Oh, no, it's perfect. And there we go. There's our graph. We know it has origin symmetry, and we can see that it has origin symmetry. And we found the x and y intercepts, which confirms when we plug in the points. And so that's the graph. And so now that we've graphed it, this is the graph of y equals x cubed. You got to know what that looks like. Just like you got to know what y equals x squared looks like and what y equals x looks like, you got to know what y equals x cubed looks like. And now that we've plotted points and we see it, that's what it looks like.